Hi, my name is Anna. Before we start the video, I just want to say thank you to Mr. Jackson and Mr. Garcia for making Algebra 2 so much fun. Of course, they helped us a lot as teachers, but they also provided us with videos so we could relate them to our math problems. So in this video, that's what I'm going to be trying to do, and yeah.
Hold on.
Gotham is under assault. Ra's al Ghul has unleashed chaos, and it's up to Batman to thwart his evil plans. But first, he needs to solve some critical quadratic equations to save the city. It's time to factor out these quadratics. They hold the key to finding Ra's al Ghul's hideout. This looks like an easy one. Factoring this equation, I need two numbers that multiply to 14 and sum up to 9. 7 and 2. The factored form is x plus 2 and x plus 7. We've got the coordinates. Now, to stop him, we need to assess the next equation. Here, I need two numbers that multiply to 20, yielding a sum of negative 12, negative 10, and negative 2. The factored form is x minus 10 and x minus 2. Time to move! But wait, there's still one more equation to solve. With this equation, I can factor out an x. It becomes x times x plus 5. With these equations factored, we can find the lines of symmetry too. Each parabola has a line of symmetry at x equals negative b over 2a. Now we could save Gotham. With a little math, even a dark night can find the light. Students make two key mistakes when solving for quadratic equations. Inaccurate factoring. Failing to verify factored forms leads to incorrect solutions. Similarly, errors in substituting coefficients or simplifying the square root of the quadratic formula. It's important to recognize these common errors so that we won't continue making them. Quadratic equations have real-world applications, like in physics and finance, showcasing their practical significance. Function's domain is a set of possible input values, and its range is a set of resulting output values. Together, they define the function's limits and behaviors. This lesson uses Spider-Man's parabolic swing trajectory to illustrate the concepts of domain and range in quadratic equations. The three example equations put here, here, and here are going to be analyzed. They each represent an upward opening parabola, resulting in a domain of all real numbers. The range is calculated by calculating the vertex, which is also called the minimum point. The range extends from this vertex value to infinity. This lesson concludes that understanding domain and range helps visualize the limits of Spider-Man's swings and reinforce the understanding of quadratic equations. One common mistake in domain and range is assuming the domain of a function includes all real numbers without considering any restrictions. While another frequent error is misidentifying the range by overlooking the actual output values produced by the function's equations. Domain and range is for understanding real-world relationships, such as population growth or financial forecasting. Rational equations are inquiries that seek clear, logical, and evidence-based responses, aiming to understand a concept or situation in a coherent manner.
It's 1/1000th our size and it's beating us.
So what do you want to do? Take it to dinner?
No.
What then?
Kill it?
In the midst of a chaotic outbreak, Colonel Sam Daniels and Major Casey Schuler are in a race against time to unravel the deadly Matobo virus. As they delve deeper into the research, they encounter crucial rational equations that may be key to understanding the virus's operation. We need to solve this equation to get a clearer picture of the Matobo virus's behavior. The common denominator for this equation would be 15. By combining fractions and simplifying, that gives us 15 minus 10y equals 27 minus 3y plus 9. Now let's combine our constants on the right side. So we have 10 minus 15y equals 36 minus 3y. If we isolate y, we can get rid of negative 3y by adding it to both sides. So that means 15 minus 36 equals 10y minus 3y. So we end up with negative 21 equals 7y. What's our final value for y? Divide both sides by 7 and y equals negative 3. Now on to the next question. We already see a common denominator on the right. So let's bring that over to the left. Multiplying both sides by x squared plus 4x gives us, expanding it out and rearranging it gives us a quadratic equation. It's everywhere. But now we can use the quadratic formula, with a being equal to 1, b equals 4, and c equals negative 6. And now the roots are x equals negative 2 plus or minus square root 10. We can tackle down one more equation, guys. Come on. This is the next equation. So we need to bring everything under one denominator. Our common denominator remains p squared minus 8p. So we could rewrite this as, this leads us to 7 plus 2p squared minus 16p equals 6. And rearranging that gives us, and with that you would apply it to the quadratic formula again, and yeah, pretty simple, guys. As Sam and Casey work together to find out the final equation, the fate of the team and potentially the world depends on their ability to uncover the truths hidden within these rational equations. Will they succeed in their quest? Only time will tell. But the math is in their favor. Rational equations are used to model real-world situations where ratios of quantity are involved, allowing for the determination of values through algebraic manipulation. Two mistakes in solving rational equations are failing to exclude values that make the denominator 0 and incorrectly simplifying expressions without properly factoring them first.
Decade of my life of being led by my nose through a dead end. They police us, they spy on us.
A system of inequalities is a collection of two or more inequalities that share the same variables and are considered simultaneously, defining a region of possible solutions on a graph. Now we're embarking on a quest to discover the secrets of systems of inequalities, starting with our first set of equations. Inequalities may seem innocent, but like any compelling case, they require careful consideration. Let's plot our first two cases. The equation for x plus 3y is greater than or equal to 15 transforms into a line when we work through its equivalent equation, forming a boundary beyond where our values must lie. But this is just the first clue. Our next equation introduces another boundary. We must discover where these regions intersect to uncover the solutions that satisfy both inequalities. Here, as you can see, they form a safe haven. These solutions are not just numbers. They are our allies in the quest of understanding. Now, let's dive deeper into another set of inequalities. Our next challenge. Each line we draw reveals a new layer of complexity. With sharp lines in shaded regions, we plot these onto our canvas. Notice how the lines interact. Only a specific area remains available to us. A crucial finding that would illuminate our path. Finally, we face our last puzzle. Once again, the stakes rise as we unveil yet another intersection. In the end, as we piece together these inequalities, we realize that we, like the unknowns we face in life, the solutions lie in understanding. The mathematical universe can be just as mysterious as the truth the agents of the X-Files strive to unveil. Keep questioning, keep solving, and perhaps you too will find the answers among the shadows. The truth is out there, and so are your solutions. System of inequalities require careful attention. 2 frequent mistakes are incorrectly reversing inequality signs when multiplying or dividing by a negative number. The second mistake, failing to properly test boundary points when determining solution sets. These errors can lead to inaccurate solutions. System of inequalities in the real world helps us understand model situations where resources are limited, guiding decision-making in areas such as economics, social issues, and environmental sustainability. Thank you guys so much for watching. I hope you guys enjoyed. Bye!